Let's talk about division. When you divide one number by another, sometimes it comes out even, and sometimes there's a remainder. For example, if I said, what's 42 divided by 7? I'd be asking, what number can you multiply times 7 to get 42? And the answer is 6. So 42 divided by 7 is 6, because 7 times 6 gives you 42. Now if I said, what's 44 divided by 7? There isn't a whole number that you can multiply by 7 and come up with 44. The closest you can get is if you multiply 7 times 6, you get 42, but then you have to add on 2 to get the rest of the way to 44. So to put it another way, 7 goes into 44 6 times, but with a remainder of 2. So you can write 44 as 7 times 6 plus 2. It's the number we were dividing by times the quotient plus the remainder. A similar thing happens when what you're dividing is not just numbers, whole numbers, but polynomials. So a polynomial like 3x cubed minus 30x squared plus 5x minus 50 divided by x minus 10, well, that means we're looking for what can we multiply times x minus 10 to end up with 3x cubed minus 30x squared plus 5x minus 50. And the answer turns out to be 3x squared plus 5. You're welcome to try it. Multiply together x minus 10 times 3x squared plus 5, and you do get 3x cubed minus 30x squared plus 5x minus 50. But sometimes the division doesn't come out even. Sometimes there's a remainder. So if you divided 3x cubed minus 30x squared plus 5x minus 30 by x minus 10, the quotient would be 3x squared plus 5, but there would be a remainder of 20. You'd have to multiply x minus 10 times 3x squared plus 5 and then add on that remainder of 20. Now, when we were dividing with just numbers, the remainder has to be smaller than the number we were dividing by. Otherwise, we could get one more 7 or whatever we're dividing by. When we're dividing by a polynomial, the remainder has to be a lower degree than what we're dividing by. So if we were dividing by a degree 1 polynomial, the remainder would have to have degree 0. It would have to just be a numerical constant. So when you have a function divided by a divisor function, you get a quotient function and a remainder function, although that remainder function might just be a constant. It might just be a number. So then you can write the function you started with as the function you were dividing by times the function you got as the quotient plus the function or number or whatever you got for the remainder. So terminology, the big function that you started with is the dividend. Then you were dividing that by the divisor, and the result, what you get, is the quotient, and if the division doesn't come out even, then you have a remainder. Okay, so how do you actually do the division? How do you divide one polynomial by another and find out what you get for a quotient and a remainder? One way, the hard way, is by long division. I'm going to show you one example of this, but I'm not going to spend too much time on it because this isn't the way we're going to be doing it. But you may have seen this before. So if I wanted to, say, divide 3x cubed minus 2x squared plus x minus 8 by x minus 2 using this long division method, here's what that would look like. I'd set it up like this with my dividend and my divisor out in front. and I look at what they start with. This starts with x, this starts with 3x cubed, and I think, what would I have to multiply times x to get 3x cubed? Answer, 3x squared. So I'm going to multiply that 3x squared by not just the x, but by this whole thing, x minus 2. So when I take 3x squared times x minus 2, I get 3x cubed minus 6x squared. I wrote that under my original polynomial, and now I'm going to subtract. 3x cubed minus 3x cubed just gives you 0, and minus 2x squared minus a negative, which would be the same as plus a positive, 6x squared, gives me positive 4x squared. Now I'm going to bring down the rest of this, and I'm going to do the same sort of thing again. I'm going to think, what do I have to multiply times this x to get this 4x squared? What times x gives me 4x squared? Well, that would be 4x. So I'm going to take that 4x and multiply by x minus 2, and that gets me 4x squared minus 8x. Now I'm going to subtract here. The 4x squared minus 4x squared cancels out. The plus x minus the negative 8x is 9x. Bring down the minus 8 and go through it again. What do I have to take times this x to get this 9x? Answer, 9. So I write plus 9 up here, and I multiply that all the way through. 9 times x minus 2 gives me 9x minus 18. Now I subtract. A negative 8 minus a negative 18 gives me 10. And I'm done. I can't go another step because I can't multiply anything times x and get just 10. So I'm done with the division. What I got up here at the top is the quotient, 3x squared plus 4x plus 9. And the number that I ended up with down here is the remainder, 10. So that's the hard way. Now here's the easy way, synthetic division. This doesn't work for all polynomial division, but it does work for all of the division that we're going to have to do in this chapter. So as far as we're concerned, for the things we need to do, we can handle division by this easier method. So here's how this works. I'm going to set it up by writing not all of the x's and stuff, but just the coefficients. The 3 and the negative 2 and the 1 and the negative 8. And then out in front, I'm going to write not x minus 2, but just the number 2. So when I'm dividing by x minus some particular number, I put that number out in front. Why is it 2 instead of negative 2? Well, one reason is that making this the opposite of this is going to mean that when I go through the division, I'm going to be doing adding instead of subtracting. Remember all that subtracting we did over here? That got kind of complicated when we were subtracting negatives. So it would be easier if I were adding instead of subtracting. So by making this, instead of a minus 2, just a positive 2, that accomplishes that. And I don't have to keep writing all of these x cubeds and x squareds and everything. I'll just deal with the numbers involved. So now that I have this set up, here's what I do. I start by just bringing down this first number, 3. Then I multiply the number out in front, 2, times the number down here, 3, and I write that here, 6. Now I add what's in this next column, negative 2 plus 6, and that adds up to 4. Now I multiply this 2 out in front times the 4 gives me 8, and I write that here. Now I add 1 plus 8 is 9. And now I multiply 2 times 9 is 18. And now I add negative 8 plus 18 is 10. And that's it. Notice the numbers that showed up here are the same numbers that I got here. I got the last number on the end here, 10. That was the remainder. And the rest of these numbers, the other numbers on the bottom, 3, 4, and 9, are the coefficients of the quotient. So the quotient is 3x squared plus 4x plus 9. So let's look at a few more examples to see if we've got the hang of how this synthetic division works. But before we go on to another example, notice what we had here. We started with this big polynomial, 3x cubed minus 2x squared plus x minus 8. We divided by x minus 2 and got a quotient of 3x squared plus 4x plus 9 and a remainder of 10. That means we can take that original big dividend polynomial and write it as the divisor x minus 2 times the quotient 3x squared plus 4x plus 9 plus the remainder 10. In this example, we are going to be dividing the polynomial x to the 4th power plus 4x to the 3rd plus 2x squared plus 9x plus 4 by the polynomial x plus 4. So to do this by synthetic division, the way we set this up is we have the numbers 1, 4, 2, 9, 4 here. Those are the coefficients of my dividend, my big polynomial that I'm starting with. And then remember how when we divided by x minus 2 and we just put the positive number 2 out in front? Here we're dividing by x plus 4, so the number out in front is negative 4. Now that's important. Pay attention to that. When you're dividing by x plus a number, you put a negative number out in front. When you're dividing by x minus a number, that's when you put a positive number out in front. Okay, so we got things set up for the synthetic division. Now, start by just bringing down this 1. Just write it down here below the line. Now multiply negative 4 times 1 and write the answer here, negative 4. Now add 4 plus negative 4 is 0. Now multiply negative 4 times 0 would be 0. Now add 2 plus 0 is 2. Multiply negative 4 times 2 is negative 8. Add 9 plus negative 8 is 1. Multiply negative 4 times 1 is negative 4. And add 4 plus negative 4 equals 0. So notice how this is a series of adding and multiplying. Add down, multiply, add, multiply, add, multiply, add, multiply, add. So now that we've done all of that, look at the numbers we ended up with. All except the last numbers give me the quotient, and then that last number is the remainder. So here we got a remainder of 0. The division came out even. And the quotient had the coefficients 1, 0, 2, 1. Now the polynomial we started with was degree 4. We were dividing a degree 4 polynomial by a degree 1 polynomial, so the result was a degree 3 polynomial. That's how I know to start with x to the 3rd power. So the quotient is 1x to the 3rd power plus 0x to the 2nd power plus 2x to the 1st power plus 1. In other words, it's x to the 3rd power plus 2x plus 1. So my original polynomial can be written as x plus 4, what I was dividing by, times x cubed plus 2x plus 1, what I got for the quotient, plus 0. Here the remainder was 0, so I don't have to add on anything else. Those two things multiply together give me the polynomial I started with. You can multiply that out and check if you want. I'm going to end this video here and come back in the next one, and we will look at some more examples and talk about why this is important, what it's good for to be able to do this.